Today, we are going to learn how to graph quadratic functions in standard form. We are going to be learning about multiple forms. Today, we're talking about standard form, okay? Standard form is when you have all your x's and the plane number on the right side, and then your y is by itself, okay? Basically, y equals, and then you have standard form, okay? Now, do you guys know what the vertex is? Some of you know? Okay, we're going to kind of draw a picture to like label some of these things. So I'm just going to draw like a coordinate plane over here. I'm just going to go out to 2 on both sides. Do you know what a vertex is?
Isn't it right in the middle?
This is your point of origin. But yeah, the vertex is in the middle wherever I graph. Okay? But it's usually we are like adding something onto what we already know. Okay? So, your vertex is this point right here. So, if I were to label that, what is that ordered pair right there? That one is 2, 2. And remember that it always goes x and then y. So, in right 2, up 2. It was supposed to. Okay, now, if your equation is written in standard form, you can find this vertex by using this equation right here. And you're going to want to end up memorizing that. But your vertex is negative b over 2a, or the x value of your vertex is negative b over 2a. Where do you think I get the b and the a value? From your equation, right? So my b value is the number with the plane x term, and negative b means whatever value this is, you would take the opposite of it, right? And then over 2 times a, and your a value is your number with your x squared term. Yes? Okay, so that's how you find the x value of the vertex, and then you find the y by plugging your value of x back in here and solving for y. And we're going to have some time to practice this. Okay. Your line of symmetry. Sometimes this is also called axis of symmetry. So just so you know both of those words, you'll see it written both ways. And then normally when I'm doing line of symmetry, I'll write that as LOS, or you could do axis of symmetry, AOS. Your line of symmetry is the x coordinate of the vertex. Okay? Your line of symmetry, we're going to do this in blue over here, is a line that goes through your vertex like that. Okay, so this dotted line right here in blue, that is your line of symmetry. Notice it's a line. Okay, so that means that when you're writing the line of symmetry, it's an equation. So in this case, what is the x value right here? 2. So my line of symmetry is x equals 2. Okay, because it's a line. A lot of people for line of symmetry will just write 2, and that is not correct because it's an equation. It's a line. So you need to have a variable and an equal sign. Okay? All right. Then you know that your graph opens up if a is greater than 0. Remember, this is your a value right here. So if your x squared term is positive, greater than 0, it's positive, it goes up. If your a value is negative, less than 0 is negative numbers, you're going to go down. Can we handle all that? Are there any questions right now? Okay, so let's go ahead and start a problem. So I wrote out some steps for you. The first thing you should do is label A, B, and C. So in this case, this equation, A is what? 3, B is, and C is 4. Okay, now, is this graph going to open up or down? And how do we know it graphs up? Because your A value is positive, it's going to graph up. Okay, so step 1 is done. Step 2, it says find the x value of the vertex. If you go back and look at your equation when you're finding the x value of the vertex, you're using the equation negative b over 2a. I would write that equation right now because then you're going to end up memorizing it if you keep writing it over and over again. Does that make sense? So I'm going to go x equals negative b over 2a. So what is negative b? What is my value for negative b? Positive 6. Good. Because right now b is negative 6 and the opposite of negative 6 is positive 6. Okay, over 2 times a, which is 3. So I end up getting 6 over 6, which reduces to what? 1. Okay, so over here I'm going to write v for vertex. I'm going to start my ordered pair, and the x value we found is going to be what? 1. Okay, but I still need to find the y value. Who remembers how I find the y value? Good. We take this x value, because this is saying x equals 1, and we're plugging it in for x into this equation in both of the x spots. So my equation is y equals 3 times 1 squared minus 6 times 1 plus 4. What is 1 squared? 1. So this really is 1. And then I have 3 times 1 is 3. Minus 6 times 1 is 6 plus 4. Then we have 3 minus 6 is negative 3 plus 4 equals 1. So my y value of the vertex is 1. Okay, so we found the x value of the vertex, we found the y value of the vertex, and then we want to state our line of symmetry. So I'm going to write LOS for line of symmetry, and the line of symmetry is always an equation, and it's going to be x equals 1, because the x value of my vertex was 1, right? And then now we're going to graph. Okay, so whenever you're graphing a parabola, the first thing you're going to graph is your vertex. So we're going to go right 1 and up 1. Remember, this is my x-axis, this is my y-axis. Going to the right is positive, left is negative, up is positive, down is negative. So positive 1, positive 1. And then we said our graph is going up, so we're going to make this curve up. And then your line of symmetry is always through your vertex at that x value. So we're going to do our dotted line there through x equals 1. Who can tell us how we know? Sydney. Good. So if A is positive, the graph goes up. If A is negative, it goes down. So basically the number in front of your equation there always is telling you the direction of your graph. Okay, so the graph along with this information right here is your answer. Okay? Questions so far? Sorry. So again, your graph and this information is your answer. This information plus the graph. Good? All right, moving on. So we have example 2 now. So the first thing we should do is what? Who remembers? Thank you. A, B, and C is correct. My A value is good, negative 3/4. B is, and C is negative 1. So my graph is going what direction? And how do we know it's going down? A is negative. Very good. The other thing we're going to want to find out is our vertex. And then we also want our line of symmetry. And line of symmetry will always be x equals a number. Whenever I'm finding the x value of the vertex, what is the equation I'm using? Good. X equals negative b over 2a. And again, I suggest you keep writing that until you have it memorized. Okay, so negative b is what? Positive 4. Good, because it's the opposite of whatever b is. Over 2 times negative 3/4. So multiply this first. So that means we have 4 over what? Negative 6 over 4. And how do you get rid of a fraction over a fraction? Good. You multiply by the reciprocal to get rid of this denominator, right? So I'm going to multiply by what? Negative 4 over 6, because you also want to get rid of that negative. Okay? And whatever I do to the bottom, I'm also going to do to the top. So on the bottom, this whole thing cancels out. Do we agree? On the top, you can always write this 4, the other number that's there, as a fraction by putting it over 1. Can I reduce anything on the fraction? What can I reduce? 6 and 4. So I can divide this by 2 and make that a 3. And we can divide this by 2 and make it a 2. So we end up with what? Negative 8 over 3. Now, if I said go find negative 8 over 3, that's kind of hard to find. So when you're doing your x value, the vertex, it's best to change this into a mixed number. Hope, did I lose you? Tell me, what's going on?
How did you get 6 over 4?
Right here?
To multiply the bottom number 2?
So this is 2 times a, right? So when you have 2 fractions and you're multiplying, you multiply the tops with tops, bottoms with bottoms. You could have even reduced this here. I just ended up reducing it up here, but however you reduce it, you'll end up with the same answer.
So then for the top one, on the right side, why did you multiply it with 6?
So I multiplied by negative 4 over 6 here to cancel that out, right? So then I multiplied the top. Whatever you do to the bottom, you have to do the same thing to the top. Anybody else have other questions on that? Okay, so if you're plotting this point, it's best to change this to a mixed number. So how do I change negative 8 over 3 to a mixed number? You're basically dividing 3 into 8. If you need to write it out as a division problem, you can. You're dividing 3 goes into 8 how many times? 2 times. We multiply that 6, so we're subtracting 6, right? It's going back to you. 2 left over. So that's 2 and 2 over 3. So negative 8 over 3 is the same thing as negative 2 and 2/3. It's much easier to find negative 2 and 2/3 on the graph than it is to find negative 8 over 3. Do you guys agree with me? So that means the x value I'm going to put here is negative 2 and 2/3. Is there anything else I could write over here that I already know? Your line of symmetry, right?
Yeah.
Is negative 2 and 2/3. Okay. What do I still need? Y. Okay. So we are going to go and plug in for y. So we have y equals. But when I'm plugging in for the y, it's best to use negative 8 over 3. Okay? So we're going to have negative 3/4 times negative 8 over 3 squared minus 4 times negative 8 over 3 minus 1. Okay, I'm going to move this up right now just so everyone can see it a little better. And then I'll move it down when we start graphing. Before I do any of this, are there questions before we move on to multiplying? We're all okay here? All right, so with order of operations, what's the first thing I should do? Exponents, right? Because there's nothing to simplify in the parentheses, so exponents. So I have this exponent of 2. So remember, does this 2 just go to one of the numbers? No, it goes to the negative 8 and the 3. So I'm going to have negative 3/4 times, and when you square negative 8, what does that become?
64.
So we have 64 over, and 3 squared is 9. Okay? And then I'm just going to rewrite the rest of these. I have negative 4. I'm going to put negative 4 over 1 and negative 8 over 3. And then I still have minus 1. So all I did right now was just did my exponent of 2. Are we good here? Okay, so now before I multiply, I would try to reduce if I can. So for instance, if you noticed here with the 3 and the 9, I can reduce that, right? Yes? Okay, so 3 divided by 3 is 1, and 3 goes into 9. Yes. Negative 8 squared, negative 8 times negative 8 is positive 64, and then 3 squared, 3 times 3 makes 9. Wait till we're done. Okay, so then I cross-reduced. Are we all okay with that there? Okay, and this is a 4. Can 4 and 64 reduce? Yeah. Okay, so 4 divided by 4 is 1, and 4 goes into 64 how many times? Okay. When I go to these fractions, can those reduce at all? No. Okay, so remember when you're multiplying, we multiply tops with tops, bottoms with bottoms. So on here, I have what? Negative 16 over 3. This is the first one, right? Negative 1 times 16 is negative 16. 1 times 3 is 3. Okay, on this next one, on the top, negative times a negative makes a positive, and on the top we have 4 times 8, which is, and on the bottom we have 3 times 1, which is, and then I have a minus 1. Well, we want, when you're adding and subtracting fractions, you want them to have what? Common denominators. So I'm going to change this 1 to be what? Three over 3, because 3 over 3 reduces to 1, right? It wasn't a trick question, but maybe it is. Okay, so I'm just going to rewrite this to 3 over 3. Okay, so now all my denominators are the same. If your denominators weren't the same, you would need to get them to have common denominators. Okay, so now we go through and we can add and subtract. So negative 16 plus 32 is how much? 16, and then 16 minus 3 is 13. 13 over 3 is my y value. But is it easy to graph 13 over 3? No, so let's change it. So we have to divide 3 into 13. How many 3s are in 13? 4, and that's 12, and there's 1 left over, so we have 4 and 1/3. Okay. Oops. So before we go to graph, are there questions on any of that math?
That was a lot of math.
It was. Are we okay? You can ask me questions. I can go back through. What? Okay, so this was 1, right? We agree that it's 1. Do you notice how both of these denominators are 3? You can make any number like a fraction, right? So I want the denominator of 3. So in order to make it 1, I would write it as 3 over 3. If these were 5s, I would have written it as 5 over 5. Okay? Other questions on the math? Okay, so now graphing. Some people feel like this is difficult. I'm hoping that you'll be okay with this. But if you want to go negative 2 and 2/3, if we go left, negative 1, negative 2, and then we have 2/3. You don't have to be exact. You're just going to be in between negative 2 and negative 3, right? So negative 2 and 2/3 is just going to be kind of like right there. Are we okay with that? And if you're going up 4/3, a positive 4/3 from there, so we're at negative 2 and 2/3, and then we're going up 4. 1, 2, 3, 4. In a third, we're just going to go in the middle there as well. So basically, what you're putting your point, it's not exactly on an exact point because a third and 2/3 is in between. Is that okay? And then which way will our graph go? Down. And again, how do we know that it goes down? Good, your A was negative. And then your line of symmetry always goes through your vertex. And so we're just doing a dotted line there through our vertex. Yes? Positive 4. The A value is what tells you your direction, and that was a negative 3/4. That's your A value. The 4 1/3 was your Y value of the vertex. Is that what you're talking about? Okay, other questions on this problem? Okay, we're moving on. Can we move on? Yes? Are you sure? I'll take any more questions. Do you have one? Ask me. Oh, it is, this negative 16/3? Okay, so going back to multiplying, this became a positive 64 because a negative squared, negative times a negative is a positive, but then you still had the negative 3/4. We're good? Awesome. Any other questions? Okay. State the x-intercepts of the parabolas. We've already talked about this. We've already been finding x-intercepts, right?
Wait, do we do the box method?
No. You're not going to do the box method on this. Why not? It's already factored right now. And when we're finding our x-intercepts, we factor and set our factors equal to 0 in order to find your x-intercepts. So remember that we're just setting this equation equal to 0. Okay, we're plugging in 0 for y. So I'm just going to cross that out and put equals 0. And then you set each of your factors equal to 0. So I have x minus 8 equals 0 and x plus 2 equals 0. And here I add 8 to both sides to get x equals 8. Here I subtract 2 to both sides to get x equals negative 2. Now, these are x-intercepts, but if you wanted to write them as an ordered pair, how would I write them? No, these are both x values. What did I plug in for y?
0.
Good, so your values are 8, 0 and negative 2, 0, because we plugged in 0 for y and solved for x. So those are my two answers. So it's really nice because on some of the problems, they're already factored for you. As long as it's y equals this, we can plug in 0 for y and we don't have to do very much work. Okay, so same thing on example 4. We're plugging in 0 for y, and so we set each of our factors equal to 0. 5 equals 0, x minus 1 equals 0, x plus 3 equals 0. 5 equals 0 does not work. Hopefully your cell phones are not out right now as we're doing notes. And then from there, on the next one, we go add 1 to both sides and get x equals 1. Here we subtract 3, x equals negative 3. And so what are my ordered pairs?
1, 0,
Very good. 1, 0 and negative 3, 0. What will we need to do on example 5? Factor. How am I going to factor example 5? You're going to have to use your over-under, exactly. So we're going to go over by 7. We have x squared. Oh, and this should be a 10. Is yours 10 on yours?
Yeah.
Good. X squared minus 10x minus 21. What multiplies to be negative? Oh, good. That was supposed to change too. Thank you.
Was that supposed to be negative?
No, it's supposed to be positive. Okay, so what ends up multiplying to be positive 20 and adding to be negative 10?
7 and 3.
So we get x minus 7, x minus 3. Those add to be negative 10, multiply to be positive 21. Am I good now? Very good. I was trying to trick you. Under by 7. Okay, and we reduce and we get? Good. And we set those equal to 0? So we get x minus 1 equals 0. And 7x minus 3 equals 0. So here we get x equals 1. Here I add 3. 7x equals 3 and divide by 7. So what are my ordered pairs? Good. 1, 0, and 3 over 7, comma 0. All right. Questions? Okay. Example 6 and 7. Get ready for some fun.
Yay, fun.
Right. Thank you. You read my mind. All right. Okay. Example 6 and 7. We're going back to some factoring after we've talked about how to do everything. And what happens on example 6 and 7 is that you have a lot more work to do. Why is there more work? Because you're going to have to find your vertex and your line of symmetry doing the negative b over 2a, but then you have to factor to find your x-intercepts, and you also are going to find your y-intercepts.
Yay.
Your you've got great attitudes. The y-intercept is actually pretty easy though. Does anybody know how we would find the y-intercept? Cody. Good. Okay, so you know how when we're finding our x-intercepts, focus, pay attention. When we are finding our x-intercepts, we plugged in 0 for y and solved for x, right? When you're finding your y-intercepts, you're plugging in 0 for x. If I plug in 0 for x here, that's going to make what? 0, and then this becomes 0, and 0 plus 0 plus 12 equals, so what's my y-intercept? 12. Okay, but what would that be as an ordered pair? Very good, because 0 for x, 12 for y. Yes. Do it again. So if you're finding your, remember when we found our x-intercept, we plug in 0 for y and we factor and solve for x. If you're finding your y-intercept, you're plugging in 0 for x. So what happens is you get y equals, and then you'd have 0 squared plus 7 times 0 plus 12. Well, these are all zeros, and 0 plus 12 equals 12. So basically, anywhere you see an x, you just kind of cancel that out because it's 0, and then you get your 12. Okay? So let's write out everything we need to know. We need to know, does our graph go up or down? Okay? We need to know what our vertex is, which is an ordered pair, right? We need to know our line of symmetry, which is always going to be x equals whatever the x value of our vertex is. We need to know our x-intercepts. So I'm just going to do that. And then we need to know our y-intercept. On this problem, we already found our y-intercept, and we found that it was 0, 12. Okay? So far, so good? All right. So now, what do you guys want to find first? Should we find our vertex? And what's the equation for finding the x value of the vertex? You guys probably already know it now, huh? Oh, but before that, my a value is what? 1. My b value is 7, and my c value is 12. So negative b over 2a is going to be what? Negative 7 over 2 times 1, which is negative 7 over 2. But when I write that in my vertex, I'm going to write that as what? Negative 3.5 is correct. Is everybody okay with how to get negative 3.5?
Yes.
Okay. How do I find the y value of the vertex? Plug it in. But you want to plug in your improper fraction because that's going to be easier to work with. So we have y equals, and we have negative 7 over 2 squared plus 7 times negative 7 over 2 plus 12. Because I went back to this equation, right? And all we did was plug in the x value of the vertex in for x. Am I going too fast? Okay, what's our next thing? Good, we're going to square these, okay? So negative 7 squared is positive 49, and 2 squared is 4. Okay, when we multiply this, we can put it over 1, and 7 times negative 7 is? Negative 49 over 2. And then I had plus 12, and we can write 12 as a fraction by putting it over 1. What would be the common denominator that we would want for this problem? It has to be at least as large as your largest denominator. So we're going to do 4. So what I'm going to do, and what I feel is easiest, and you can do whatever way you want to, I just like to rewrite each of my fractions and just put a 4 in the denominator. And then I go back and look at my original problem. So on this first one, did anything change? No. So I'm just going to rewrite 49. On my second one, 2 times what makes 4? 2. So I have to go 49 times 2, which is? Good, 98 is correct. Okay, on the 12 over 1, what did I have to do to 1? By 4, so that means I have to multiply 12 by 4, which is 48. Okay, not too bad, right? And then we have to go through and combine. So 49 and negative 98 makes what? 49. Okay, it makes a negative 49. Okay, so those two make negative 49, and then negative 49 plus 48 makes a, so I have negative 1 over 4. Are we okay? So I added these together. 49 and negative 98 make a negative 49, and negative 49 plus 48 makes negative 1. Okay, keep your denominator the same. So going back up here, my vertex is negative 3.5, comma, negative 1/4. My line of symmetry is what? X equals negative 3.5. How do I find my x-intercepts? Good. We come back up here. We set the y equal to 0, and then we have to factor. Okay? So I'm just going to kind of take this information. So what multiplies to be 12 adds to be 7? X plus 4 and x plus 3. And when we set those equal to 0, x equals what? Negative 4, negative 3. But those are two separate points that it's intercepting at, right? And what are those as ordered pairs? Okay, so negative 4, 0, and negative 3, 0. So now we can graph. What? Oh, yeah, thank you. And which direction was it? It was up. And how do we know that it goes up? A is positive. Okay, so we have all of these. You have 1, 2, 3, 4 things, 4 points to put on to make your graph more accurate. Okay? So negative 4, 0, left 1, 2, 3, 4, 0. And then you also have a negative 3, 0. Which are pretty close, but that's okay. Your vertex is at negative 3.5, comma, negative 1/4. Well, negative 3.5, you go 1, 2, 3.5. It's right in between those two, isn't it? And then down 1/4 is going to be just in the middle right there. I know. Kind of, huh? All right. And then the other point I have is my y-intercept, which is at 0, 12. This goes up 10, and so it's going to be a little off the graph there. And then you're going to make your curve. So my curve goes down like that and up. Okay. X-intercepts. Remember, this is your x-axis. Left is negative, right's positive, up's positive, down's negative. We went negative 4, 0, made that point. Negative 3, 0, made that point. Your vertex is at negative 3.5, so that's right in between negative 3 and negative 4. And then you went down negative a fourth, so it's just not quite to negative 1. It's in between 0 and 1. Are we okay? It's just really close, and it is. This next example is better. Well, like when I say better, I mean there's no fractions. Okay. There's one thing I didn't put on there. What did I forget? Your line of symmetry. So it's just a dotted line there through your vertex. Okay. Example 7. I think you guys have a different problem than I do. Y equals x squared plus 6x plus 5.
We have 2x squared plus 6x.
Okay, change it.
Wait, did we change it?
Yes. Yes, please. I mean, thank you. All right, so same thing. Let's write down everything that we need. We need your graph. We need your vertex, your line of symmetry, your x-intercepts, and your y-intercept. Oh, and you know what? I forgot something.
No, you're fine. No, you're good. Seriously, you're fine.
We'll just talk about it once we're done.
Okay.
Okay, so what's the easiest thing to do?
Find y.
Okay, what's the y-intercept going to be? As an ordered pair. 0, 5. How did we find that that was 0, 5? 0 for your x's, which means these will cancel out, and it'll just be a positive 5 for y and 0 for x. Okay, what are my a, b, and c values? Great. Which direction is my graph going to go? Very good. How did you know it's going up? Very good. Vertex. How do I find the x5 of my vertex? Good. X equals negative b over 2a. What is my negative b value? Negative 6 over 2 times 1. Negative 6 over 2, which makes negative 3, and that makes us happy. I know. Okay, how do I find the y value? We plug it into this equation and solve for y. So we have y equals negative 3 squared plus 6 times negative 3 plus 5. What is negative 3 squared? Positive 9. What is 6 times negative 3? Negative 18 plus 5. And we simplify. 9 minus 18 is negative 9, and negative 9 plus 5 is, so the y value of my vertex is negative 4. What is my line of symmetry? No. 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 Diego is saying it. X equals negative 3. Don't forget that. You're going to get it wrong. Well, okay. How do I find my x-intercepts? 0 for y and factor, right? So we're taking our equation and we have x squared plus 6x plus 5 equals 0. What multiplies to be 5 and adds to be 6? Good. So we have x plus 5, x plus 1, which means x equals negative 5 and how do I write those as ordered pairs? Okay, now we need to write everything or plot everything on the graph. So, we have negative 3, negative 1, 2, 3, 4 for my vertex. My x-intercept is at negative 5, 0. And then the other one is at negative 1, 0. And then my y-intercept is at 0, 5. So when you graph it, it looks like that. So basically, by finding your x-intercepts and your y-intercept, I did something wrong. It makes your graph more accurate. Yes? Yes, Hope. That's your y-intercept, 0, 5. What? This right here is your vertex. Good. Where is my line of symmetry? Don't put this away yet. I told you I forgot something. Okay. So, it's also going to ask you what the maximum or minimum value is. So if you looked at this graph, what do you think the maximum or minimum value is? Okay, so I look at this graph right here, and this looks like, first of all, do you think this is a maximum value or a minimum value? Minimum, because everything else is bigger, right? But at this point, you guys said 5, but I disagree. What value is this? Negative 4. So my minimum value, minimum equals negative 4. So now that you know this, go back to example 6. Do you have a maximum or minimum value on there? Maximum or minimum? You're only going to have a max or a min. It's not going to be both. So if you look here, this is a minimum value because everything from this point above is bigger. So I have a minimum value and everything else is greater, and this minimum was at negative 4. So this is a minimum. Yeah, sometimes graphing at first helps you. And what is that minimum value? Negative 1/4. Okay, let's go back and check this. Yes. Where did I put maximum? Because it's not a maximum, it's a minimum value. Right, it's only going to be a maximum or a minimum. Because this is a minimum value. This is like the minimum value and everything else will be bigger. You would have a maximum if your graph is going down because you would have a maximum value and everything else will be smaller. Does that make sense? Okay, so go back to example 1 and 2. Example 1, is this a maximum or a minimum? Minimum, and what is that minimum value? This minimum value is at 1. Okay? What about example 2? Maximum, because everything else is smaller. And what is that maximum value here? 4 1/3. Okay?